Good morning friends, welcome to my YouTube channel. Today we are going to study series RLC circuit. Here we will study the AC current, voltage and power factor in series circuit with resistance, inductance and capacitance. Here in this first circuit, here is a resistance of 20 ohm and supply voltage AC supply voltage 230 volt AC. The current I is equal to V upon R. Current I is flowing in phase with the voltage. Here is the vector diagram. In this case, voltage is 230 volt and resistance is 20 ohm. Therefore, current I is equal to 230 by 20 ohm is equal to 11.5 ampere. Angle between the current and voltage is 0 degree. Here is the vector diagram. This V voltage and this is current I and V is in the same phase. The voltage V here 230 volt and I is equal to 11.5 ampere and the angle between these two is 0 degree. So it is the case of resistance. In case of inductance, the current will lagging with the voltage, and in case of capacitance, the current will lead the voltage by 90 degree. Here in this case, inductance is connected to the supply voltage. In case of inductance, we have to take the inductive reactance of inductance. Here, inductive reactance XL is equal to 2 pi FL. So, I is equal to V upon XL. In this case, current is lagging voltage by 90 degree. Here is the vector diagram. In this case, we have taken inductance is equal to 0.5 Henry. So, voltage is equal to 230 volt. Inductance L is equal to 0.5 Henry. XL is equal to 2 pi FL is equal to 2 into 3.14 into 50 into 0.5 is equal to 157 ohms. Therefore, current I is equal to 230 by 157 ohms. It is equal to 1.46 ampere. So, here in this case of the inductance, current is always lagging by voltage by 90 degree. Here is the vector diagram. This is voltage vector. This is current vector. This current vector is lagging 90 degree by voltage. This direction is lagging, this is leading direction. Here we can say voltage is leading current by 90 degree or current is lagging voltage by 90 degree. Both are the same things. So it is the case of inductance. Now in third page I am showing the effect of capacitor. Here in this case, capacitor of 2 microfarad is connected to 230 volt 50 amp supply. In case of capacitor, we have to take capacitive reactance. At capacitive reactance X is equal to 1 by 2 IFC, it is formula, and I is equal to V upon XC. In the case of capacitor, current is always leading by 90 degree. Here voltage is equal to 230 volt, capacitor is equal to 2 microfarad. X is equal to X is equal to 1 by 2 pi FC is equal to 1 by 2 into 3.14 into 50 into 2 into 10 to the power minus 6. यहाँ पर 10 to the power minus 6 इसलिए करते हैं कि इसको माइक्रोफैराड से फैराड में कन्वर्ट कर दें. Then this X is equal to 1592. So the current I is equal to 230 upon 1592 is equal to 0.144 ampere. Current is leading voltage by 90 degree. Here is the vector diagram. Current is 0.144 and voltage is 230 volt, and here current is leading 90 degree by voltage. So in this case it is the capacitor. Whenever a capacitor is connected in AC circuit, the current is always leading the voltage by 90 degree. So we have seen that in case of resistance, current is always in the phase of voltage. In case of inductance, current is always lagging 90 degree by voltage, and in case of capacitance, current is leading voltage by 90 degree. So there is a different characteristics of inductance and capacitance and resistance. Now we will see the series RLC circuit in the next page. Friends, here This is the circuit of series R and L. Means resistance and inductance is connected in series with a supply of 230 volt AC. Here this is the resistance R is equal to 100 ohm, inductance L is equal to 0.5 Henry, supply voltage is 230 volt 50 Hz. So resistance is equal to 100 ohm, inductive reactance XL is equal to, given by formula 2 pi FL, this is equal to 2 into 3.14 into 50 into 0.5 is equal to 157 ohms. In the case of AC circuit, impedance plays an important role. Impedance is denoted by Z. Z is equal to under root R square plus XL square. In this case, under root 100 square plus 157 square is equal to 186.14 ohms. So current in AC circuit, current is equal to voltage upon impedance V upon Z. Here in this case 230 voltage upon 186.14 ohm is equal to 1.23 ampere. It is the current flowing in this circuit. This current I is equal to 1.23 ampere. This current flows through the resistance and inductance simultaneously. So in case of AC circuit, cos phi is equal to R by Z is equal to 100 by 157 is equal to 0.636. So cos phi is equal to 0.636, therefore phi angle is equal to cos inverse 0.636 is equal to 50.6 degree angle. Here the voltage across inductance is equal to VL is equal to I current multiplied by XL. XL is 157 ohms. So VL is equal to 193.11 ohm, and voltage across resistance is equal to I into R is equal to 1.23 into 100 is equal to 123 volt. Means here across this resistance voltage is equal to this 123 volt, and here across this voltage is equal to 157 volt. So now come to the vector diagram. In this vector diagram, current is taken as a reference vector. Here current is equal to 1.23 ampere, and voltage across resistance VR is taken in phase with the current vector. So this is current vector, this is voltage across resistance, it is in phase with the current. This VR is equal to 100 volt, and voltage across inductance VL is 90 degree leading to the current vector. So it is 193 volt. The resultant vector of these two vectors VL and VR is equal to this V. V is the resultant voltage, that is the supply voltage 230 volt. Means this supply voltage 230 volt is equal to resultant of VL plus VR. Means it is vector sum of these two voltage, and this is the final current angle of the between voltage and current. Means it is upon applied voltage 230 volt, it is actual current 1.23 ampere, and this is the angle between current and voltage, that is 50.6 degree, and the power factor is equal to cos 50.6 degree is equal to this value, this 636 is the power factor. So this is actual angle. This angle gives the power factor value. Power factor is the cos phi of this angle. This is actual current IR. This is voltage VR, VL, and it is resultant voltage, means applied voltage 230 volts. So if you see, this is 123, it is 157. If you sum directly, then it is more than 230 volt. So it is not directly sum, it is the vector sum of these two voltages. So in this case, we have seen the series circuit of R and L, and next page I am going to dealt about RLC series circuit and its vector diagram. Here in this page I am showing a series RLC circuit. The value of resistance is 100 ohm, value of inductance is 0.5 Henry, and value of capacitor is 15 microfarad. capacitive reactance of capacitor is equal to 1 x is equal to 1 by 2 pi fc. Here 1 by 2 into 3.14 into 50 into 15 into 10 to the power minus 6 is equal to 212.3 ohms. Similarly, inductive reactance XL is equal to 2 pi FL formula is equal to 2 into 3.14 into 50 into 0.5 is equal to 157 ohms. The impedance of the circuit is equal to under root R square plus ब्रैकेट में XC माइनस XL का होल स्क्वायर, या 100 स्क्वायर प्लस अंडर रूट में 212.3 माइनस 157 का होल स्क्वायर, here 100 square minus 55.3 का whole square is equal to 114.27 ohm. So the total impedance of this complete unit, resistance plus inductance plus capacitance, is equal to 114.27 ohms. Therefore, the current is equal to V upon impedance is equal to 230 volt upon 114.27 is equal to 2.01 ampere current. Means in this circuit, the current flowing will be 2.01 ampere. Again, the cos phi is equal to R by Z is equal to 100 upon Z 114.27 is equal to 0.875. So phi angle between voltage and current is equal to cos inverse 0.875 is equal to 29 degree. Now come to the vector diagram. Here voltage across inductance is equal to I into XL is equal to 2 ampere current I multiplied by 157 is equal to 315.57 volt. Means voltage across this inductance is 357.5 volt. It is always more than that applied voltage. Again, voltage across capacitance is equal to I into XC. Therefore, Vc is equal to 2.101 into 212.3 is equal to 426.7 volt. The voltage across this capacitor is equal to 426 volt, and voltage across resistance R, I into R is equal to 2 into 100 over 200 volt. So we see the voltage across resistance is equal to 200 volt, voltage across inductance is equal to 315 volt, and voltage across capacitance is equal to 426 volt. So we see that 315 volt is all more than 230 volt, 426 is also more than 220 volt. So we will find total voltage with the help of vector summation of these three voltage. Here the vector diagram is shown. In this vector diagram, we will take current as a reference vector. This 2.1 ampere current is a reference vector. This is horizontal line. The voltage across capacitance is leading the current. Means current is lagging. So voltage across capacitance is leading the current. So Vc is equal to, this is 426.7 volt here, and VL is equal to 315.57 volt here. So when we find the resultant, we have to subtract this 315 volt from this 426 volt. So Vc minus VL is equal to 120 volt is here, and VR is equal to here 200 volt. So the vector sum of these two voltages is equal to V is equal to 230 volt. This 230 volt is the actual supply voltage. Means this 230 volt supply voltage here is divided into three vectors. One vector is VR. This is in parallel with the current vector. Means it is in line with the current vector. Means voltage drop across the resistance is always in phase with the current vector. And voltage across capacitance is leading the current vector, and voltage across this is lagging the current vector. Means current is lagging and voltage is leading. So this voltage VL, VC and VR, all these three voltages, resultant voltage is V volt, and this is the current 2.01 ampere. It is the angle between current and voltage. This is also known as power factor angle. So cos 29 degree is the power factor, that is 0.875. So in this way, this is complete series circuit which is having resistance, inductance and capacitance. I think this circuit and calculation will be helpful to you. And I request, please, if you like it is useful, please like my video and subscribe my channel. Thank you very much.